Mastering machine learning security. You're flying blind without proactive model monitoring and logging strategies. When considering the implementation of model monitoring and logging techniques in a machine learning production environment, what specific strategies and best practices do you employ to ensure the detection of data drift, model degradation, and other operational issues, and to facilitate the diagnosis and remediation of these issues in a timely and effective manner? To ensure the detection of data drift, model degradation, and other operational issues in a machine learning production environment, and to facilitate the diagnosis and remediation of these issues in a timely and effective manner, the following strategies and best practices are employed. Model monitoring. 1. Define and track key performance indicators, KPIs. Establish a set of metrics that measure the model's performance and health, such as accuracy, precision, recall, F1 score, and latency. These KPIs serve as the foundation for identifying potential issues. 2. Real-time inference monitoring. Implement real-time monitoring of model inference to capture data distribution changes, concept drift, and anomalies. This allows for swift detection of potential issues. 3. Statistical process control, SPC. Apply SPC methods to monitor the distribution of model inputs and outputs, enabling the detection of subtle changes and anomalies. 4. Model explainability and interpretability. Implement techniques such as SHOP, LIME, or tree explainer to gain insights into model decision-making, facilitating the identification of issues and biases. Data quality and drift detection. 1. Data validation and verification. Validate data against predefined schemas and perform regular data quality checks to ensure data integrity and detect potential issues. 2. Data profiling. Create and maintain data profiles to track statistical properties, distributions, and correlations, enabling the detection of data drift and changes. 3. Drift detection algorithms. Employ algorithms such as ADWIN, Page-Hinckley, or statistical process control to detect data drift and changes. 4. Sensor and data source monitoring. Monitor data sources and sensors to detect issues such as data quality problems, sensor malfunctions, or data siloing. Logging and auditing. 1. Centralized logging. Implement a centralized logging system that collects logs from all components of the machine learning pipeline, including data ingestion, model training, and model serving. 2. Structured logging. Use structured logging formats such as JSON or CSV to facilitate log analysis and querying. 3. Auditing and version control. Implement version control for model training datasets, models, and code, and maintain an audit trail of all changes, updates, and deployments. 4. Log analysis and alerting. Utilize log analysis tools and alerting systems to detect anomalies, identify trends, and notify relevant teams of potential issues. Collaboration and communication. 1. Cross-functional teams. Establish cross-functional teams consisting of data scientists, engineers, and business stakeholders to facilitate collaboration and communication. 2. Incident response plan. Develop and regularly exercise an incident response plan to ensure timely and effective remediation of issues. 3. Communication channels. Establish clear communication channels and protocols for reporting and addressing issues, including email, chat, and ticketing systems. 4. Knowledge base and documentation. Maintain a knowledge base and documentation of issues, solutions, and best practices to facilitate knowledge sharing and transfer. Continuous improvement and refining. 1. Post-mortem analysis. Perform post-mortem analyses of issues to identify root causes, and develop and implement mitigations and improvements. 2. Regular model retraining and updates. Regularly retrain and update models to adapt to changing data distributions and maintain performance. 3. Automated testing and validation. Implement automated testing and validation of models, data, and pipelines to ensure consistency and quality. 4. Feedback loops. Establish feedback loops between data scientists, engineers, and business stakeholders to ensure that insights and issues are addressed and incorporated into the machine learning pipeline. By employing these strategies and best practices, organizations can ensure the timely and effective detection of data drift, model degradation, and other operational issues, and facilitate the diagnosis and remediation of these issues in a machine learning production environment.